Okay, here we go. This is a video for year 12 IB physics to try to learn how to use Logger Pro to make a graph like you're seeing right here. It's got 3 lines and it's used to do lots of experimental reports. So this was your first experiment. Now the instructions were here. So these were the instructions you were given. Dropping a ball, given an equation. You don't need to read all this. You can do a screenshot. You can read it yourself. Also, in the instructions, you were given this long, detailed process. There's a warning here in red. You might want to screenshot this and pause the video and have a read. Most of the video is going to be how to use Logger Pro to turn your data table, which is something like this, your data table that has the drop heights and all of your different trial runs and your average time to fall, to turn something like this into something like this. So that's the video's purpose. So here we go. Let's start a new video. Let's start a new file. So when you open up Logger Pro, you've got these things, X and Y, and a blank graph. What you want to do, if you've already plopped it into Excel and worked out things, is you can copy and paste things across. If you haven't worked things out in Excel, you could just type up your values. But I use Excel to do the averages of these 3 numbers, so I don't have to. So that's the code, if you want to pause the video and have a look, to get the averages for the 3 trials. But since I can do that, I can just copy and paste. And we have all the data that you would start with. Now, it's not X, it's the drop height. So you double click on this and you go to the first screen that pops up and you relabel it drop height. I always include the letter for the symbol in the formula as well. The short name is H. The units were in meters, and you click done, and now it's changed the X to height from H in meters. Same thing for the Y. These were the average time to fall, which I'm just calling lowercase t. So that also goes in the short name, and the units were in seconds. And you click done. And that's that. Now, as you can see, the graph is a bit munted. We want to change the bottom number. You just click on it, and you can type in 1.1, enter. Let's try that again. 1.1, so you can actually see a little bit more. And the vertical axis, you can change that by just clicking on the number and typing something a little bit larger than the largest value. So I'll go for 0.5. So there's your data. It's a curve. You're close to the curve, so it's hard to see it's a curve. Now, in your instructions, remember, this is not the graph that we actually want. This is the graph of the raw data. In your instructions, we actually want a time squared versus height graph, or a height versus time squared graph. It's better if it's a height versus time squared graph, because then it pairs up with this supplied formula where the height is on the y-axis and the time squared is on the x-axis, because then your gradient will be 1/2 of g. Now, how do we do that in Logger Pro? We need a new calculated column. So we just need to insert a new calculated column, which is actually on the data drop-down menu. New calculated column. This is going to be the average time squared, which also will put t with little arrow above the 6 and a squared, and the short name t with little arrow above the 6 and squared, and the units are also seconds squared. And it won't let you do it until you tell it how to calculate it. So that's Logger Pro for you. So right here you click and you just select from these here. You want the time. The arrow above the 6 and a 2 tells it to square it. Now you click done, and now we have these blue values. So we can expand this window a little bit, scroll back, and now we have all 3. Okay? So the original height, the time, and the time squared. Now, insert a new graph. There it is. it hasn't made the graph we want. It's put the time squared on the vertical and the height on the bottom. Remembering, we want height on the vertical and time squared on the bottom so that it fits the y equals mx pattern and we have a gradient of 1/2 g. So you click on this and you tell it, no, I want the drop height. You click on this and you say, no, I want the average. Now you have to redo the axes. The easiest way is to double click and this window pops up. The y-axis, the vertical axis, which we have the drop height, we want to go from 0 to 1.1, so you got to change the bottom to 0 and the top to 1.1, a little bit larger than the biggest value. And the x-axis is down here on the bottom. So the left we want to read 0, and the right we want to read a little bit larger than the largest blue number. And the largest blue number is 0.2, so we'll go 0.21. Done. So there's our dots. Nice little happy straight line. Okay? So, we're close. Now, back to your instructions. We have to work out the error bars. Okay? So the error bars, actually this might be a good time to show you this. This is my plan, rather than the plan you were given. So you might want to pause the video and have a good look. We've already done quite a few of this. We are now up to number 5. Okay, so if you haven't already paused it, here we go. We're going to work out the error bars for our time squareds. And how we do that is we look at our data and we say which of these time squared values have a big variance or a big difference from the 3 numbers that they came from. So one way to look at it is to notice that this one right here versus that number right there have a difference of 0.007. Now, it's sort of hard to see that. What you could have done is you could have calculated all of the possibilities and then just find the largest. When you're hunting, you might have noticed that this one down here, we'll make it blue, is about 0.005 away from that one there. But 0.005 is smaller than 0.007. So what we're going to do, you hunt down the biggest difference from the average and the numbers that it came from. And that's what we're going to use for our error bar on all our t-squared values. So we have to remember the 0.007 is the uncertainty on the average, and we graphed time squared. So we have to use the uncertainty rules, which says here, use the uncertainty rules to work out the uncertainty on the time squared value, not the uncertainty on the time value. So over here, I have shown you the logic that we're going to be using. The uncertainty divided by the number times 2, because we're squaring it, times by the number that it's of. So it's a bit tricky. Have a good look. Anyway, it works out to be 0.004. So the uncertainty of 0.004 is on the 0.103 value. So the third time squared value has that uncertainty. So we're going to go back to Logger Pro and tell it everything on the t-squareds has an error bar. And we double click. We go to Options, the second tab, right there. You click that, and 0.004. So we click Done, and now we have all of these error bars on the time squared values. It goes right and left 0.004. So back to my instructions.